package 4, we work for the development of new technologies with a special focus on secondary lines. Then, for example, we have trackside measurements to measure the vibrations of the track, of the switches or the crossings. The development of new mobile phone technologies, so particularly for checking the comfort of passengers. Then also axle box acceleration, that is a technology where accelerometers are installed in the axle box, and then whenever the wheel passes over defects, joints or any asset, then we can detect the vibrations, and by looking at differences we can see if maintenance is needed over there or not. New interlocking systems, positioning also, and ways to convert knowledge, sensor information into managerial information for maintenance.
It is about one low-cost system which has a objective to monitor, to collect acceleration data from a plane line and switch and crossings, and also to collect data from a contact line level. The system is composed by 3 devices working together, but everyone have functions differently and provide different functionalities. First device we talk about now for the example of the plane line and switch and crossings. First device, it's the sensor device. It's named wireless sensor device for rail, which look like this. Will be placed on the foot of the rail, and this block of resin contains all components, electronic components, the battery, the photovoltaic cells, all needed for having a good transmitting data many times. Also inside this block are one performant accelerometer, 3-axis accelerometer with many interactive functions. The photovoltaic cells, here it's visible, will provide enough power and enough energy to charge the battery in time of the day, and the microcontroller having a very low power consuming in the night will keep the battery functioning, will not be depleted over the night. Yes, this is the concentrator device, which will be placed one pole aside the track, and will collect data from all network from his family, because now our development stage will make only 7 accelerometers for one mini network to send to one concentrator. So our network is composed by 7 sensors on the line level and 1 accelerometer. After collecting data from accelerometer in the field, the concentrator will send all data volume package through one cable, serial communication, to the long-range communication device, which is one device using Wi-Fi communication to send a high volume of data to anywhere for analysis and for storage and also. So the same system, it's designed, only mechanical differences, is designed for monitoring acceleration and displacement of the contact line. For this type of sensors, the block of resin will be placed on this plate with this mechanical fastening. Otherwise, differences are minor between the system for monitoring switch and crossings and the system for monitoring acceleration of the contact line.
Into the Rail project, ADES was developed on mobile application in order to identify the comfort of passenger during the travel on the rail, and as a way to identify the possible bugs into the track of rail networks. This application was developed in accordance with standard ISO 2060-31. This standard provide a basic evaluation of crest factor of vibration. The data collected by the mobile application are separately into two types of data. The first type of data is regarding to the subject, in fact route or rail units, and other data is the dynamic data, are related of the three-way direction of acceleration, roll and pitch acceleration, speed of travel, position, latitude and longitude provided by networks or by the GPS, and other information is related to the accuracy of position. This is very important because the accuracy provides to the end user the exact position of bed comfort of or bed track. Our application offer a low-cost solution in order to identify the passenger perception of travel and big malfunction into the track. We can obtain information regarding the geometry of track. This aspect doesn't possible observation by the visual inspection.
The high-speed video camera system has two objectives in the project. First objective is to film the contact line and displacement of the contact line. In this case, the camera will be mounted aside the track with a fixed objective and will film a segment of contact line. The second objective of the camera is more challenging, means camera mounted on the roof of the locomotive and filming the possible and probable arcs of the contact line. It's very dangerous for camera. It's could be destructive for the camera because the camera will be placed above the locomotive on the roof. And for this reason we made steel case, and for this reason should be processed with specialized software for image analyzing, because it's most important not to see the displacement of the contact line, but also to quantify this displacement as millimeters precision. Composition of the sparks is needed a specialized software to see frame by frame rising of the sparks, decreasing directions of flames, also to see the colors of the spikes, because the colors of these sparks means copper burning or means steel burning.
Well, we are here at VAUREI Testering in Romania, and we are testing our ABA test system that we developed at Delft University of Technology. ABA stands for Axle Box Acceleration, and that's exactly what it does. We are measuring the acceleration of the axle box, and that is this part that contains the wheel bearing of the train. We are measuring in different directions the vibrations of the axle box, and we do that by putting small sensors. You can see them here. We mount them on the axle box. They can measure in the vertical, longitudinal and lateral direction. These vibrations give us information about the behavior of the rail, the rail construction, when it is excited by the wheel of the train. And each vibration gives information about the type of defect and the size of it. What we try to do is to find the fingerprint of each defect. If we have found a certain defect and we are measuring it, let's say every 4 weeks, of course we can see the development of the defect. Is it growing? Is it stable? Or sometimes it can be disappearing because of wear. So with the ABA system we can see what the condition of the track is and if maintenance is necessary and when it is necessary. Yes, for us it was really exciting to run at and to measure at 200 kilometers per hour, because in the Netherlands we can go up to 100, 140 kilometers per hour. And as the response of a defect also depends on the speed, because that's the excitation that you and the energy that you put into the system. The fingerprint will change with speed. So to calibrate the ABA system, it is important to do it at different speeds with the same defects. And at the test ring here at Vauwrij, we are able to run different measurement runs on the same track with different speeds. And so we can compare the differences between speed and the fingerprint that we found.
In Europe we use several interlocking systems. It's the most modern computer-based interlocking systems. Relay-based interlocking system a little older, but very sure, very safe in functionment. And there are also in use in many countries in Europe some old systems based on mechanical and electromechanical elements, which are not so safe like the other one. Our system is dedicated to those old and obsolete, let's say the truth, systems, because they have some deficiencies. The new systems has complete controls about the switch points and the signals. They control also the commands and also the real execution of those commands. In mechanical, electromechanical systems, the cycle is not complete. We gave a command, but we don't know if it's executed as commanded. So our system provides real-time information about the position of all the mechanical and electromechanical and all the mechanical elements as signal arms or blades switches position. For the signal, the problem is a little easy because their movements, the arm movements, are large, so it's easy to detect their position with some cheap elements. For the switches, the tolerance of the blades are about a few millimeters, so we must use some certified blade detector position. A little, it consists of several acquisition modules like this one I can show here, which has some power supply, autonomous power supply formed by a photovoltaic cell and a battery of lithium-ion chemistry, which assure their use practically unlimited. By here enters the cables which goes to the elements which must be monitored. Radio network implies also some the central unit, this one, which receives the data information transmitted by the acquisition modules. The data that is received by this control unit is sent via serial cable to a laptop. All the data are logged in the data logger and also are provided to the central signalman on a graphic display. So the central signalman knows in real time what the position of every element of the station is and may take the necessary actions.
Here the guys are measuring track side vibrations, so they have installed accelerometers in the crossings at different places, and then whenever the excitation, the train is passing by, We measure the vibrations, we can check the natural frequencies of the crossing, and this information, together with Axle box acceleration, give us a full set of data about how the crossing behaves. So this is very useful later for modeling, for analyzing of numerical methods and so on.